Now the next problem is two fixed horizontal frictionless inclined plane making an angle 30 degree and 60 degree with the horizontal are shown in the figure. Two blocks A and B are placed on the two planes. What is the relative vertical acceleration of A with respect to B? Okay. Now we know that the acceleration of block A along the incline and acceleration of block B along the incline is given by g sine theta. Okay, where theta is 30 degree and here it is g sine 60 degree. Okay, now if a particle has an acceleration, let us say A, then its horizontal component, vertical component, if let's say this angle is theta, will be given by A cos theta and this will be given by A sin theta. Now in case of A and in case of B, the acceleration here it is g sine 60. So the component in the horizontal and component vertical, if you find out, and this angle will be 60 degree because this is 60, therefore this is also 60 degree. So the component of this acceleration in the vertical direction will be g sine 60 into sine of 60. Okay, this you can write it as g sine square 60. Similarly, in the case of B, the vertical acceleration would be g sine square 30. Okay, now if you substitute the values of sine 60, this will come 3g by 4 and this will come as g by 4. So the acceleration of A and acceleration of B, if you take the relative acceleration, you will get 3g by 4 minus g by 4 equal to g by 2. Okay, now this acceleration is relative acceleration in the vertical direction. Okay, which will be equal to 9.8 divided by 2 equal to 4.9 meter per second square. Okay, so option D is correct. Now let us look at the next problem. For a particle in uniform circular motion, the acceleration A at a point P given by r and theta, where r is the radius and theta is measured from the x-axis, will be given by. Okay, so if a particle is executing circular motion which is uniform, that means it has only centripetal acceleration, and that centripetal acceleration is v square by r. Okay, now you have to take the components of this in x and y direction. So the acceleration, if let's say this angle is theta, okay, that the point P makes with the x-axis, then this is also theta. Okay, so this acceleration v square by r will have two components. One is this, another is this. This will, and this angle is theta. So this is a cos theta and this is a sin theta. Now you can see that this acceleration is in minus x direction. So the direction is minus I cap and here it is minus j cap. So the acceleration vector can be written as minus of v square by r cos theta I cap minus v square by r sin theta j cap. Okay, or you can also write it as minus v square by r cos theta I cap plus sin theta GCAT. Okay.